All right, welcome back, everyone. We're now going to go to the last discussion for today, and it's going to be SIG Cloud Provider and Provider OpenStack, moderated by Anusha and Christoph. So with that, I'll hand it over to them.
So hello. Just a few words. So just a few words to me. As I mentioned before, I'm working a little bit on Edge stuff, but also on the cloud provider OpenStack. And today we want to discuss what happens there, why we need it, and if you are using that would be very interested. And when you are not using it, why you are not using it, and where we can help as the maintainers of this project to go further and help you in using it. Yes. Anusha, is there anything to add?
Yeah. So, audible, right? Hello?
Yeah, we can hear you.
Yeah. Okay, thanks, Chris. So, I'd like to start a little bit introduction about myself. So, I'm Anusha, working for NEC as a developer and also the co-lead for the provider OpenStack project. So, yeah, I think please log the names of the parties who want to participate, and asterisk before your name so that we can invite you to the discussion. Okay, for those who are new to the project, so a little bit of background about the project. So SIG Cloud Provider is a special interest group within Kubernetes, which focuses on cloud provider integration. So provider OpenStack is a sub-project of that SIG. And for any Kubernetes deployments on top of OpenStack Cloud, provider OpenStack acts as an interface between Kubernetes and OpenStack. So this enables Kubernetes to talk to underlying APIs and leverage various of its services, etc. So that's a brief introduction about the project. As part of the project, we host a number of plugins as well. So OpenStack Cloud Controller Manager is one of the main components, which is an implementation of external cloud provider. So I think poll is up. We can start the discussion on that. Chris, over to you.
Okay, then let's get ahead. So I think the next poll kind of thing on how you deploy Kubernetes on OpenStack, we can a little bit skip because we had that in the previous section, and I think there was a huge amount of Magnum users. So I assume that that all the other options are. Maybe I want to know what the other people that are not using Magnum are doing to get the cloud provider running, because Magnum does it for you. Kind of. Is there anyone who uses something like, let's say, just kubeadm and has deployed cloud provider OpenStack, or the cloud controller manager, to be more precise? Seems not to. So then I just step a little bit.
So I did something on the OpenStack provider, but that is using Kubernetes cluster API. OpenStack provider for, so that is still, the work is going on. It's not still completed, but it's in the development mode in the cluster API under OpenStack provider.
That's great to hear, because we have some options here maybe that are not yet with the new style of let's say, new style of Cloud Controller Manager. So maybe the question is, should I tell a little bit about how why we need the cloud provider OpenStack Cloud Controller Manager, or why it's there and why we are not why we don't want to use the in-tree Kubernetes one anymore? Maybe
Sure.
that would be good.
Sure.
Because I don't know how familiar the people are here. So in the old days of Kubernetes, we have cloud providers in-tree, which is, they are in the Kubernetes binary, specifically in the Kubernetes binary of the Kube Controller Manager. And that takes care to talk to your cloud provider. Let's say if you have a service type load balancer, then it went to either Octavia or the Neutron LBus API and takes care that the load balancer is in place. So that's great. But we have a number of cloud providers out there, and you have to compile everything into this single binary. So now we have, in the Kube Controller Manager, we have OpenStack, we have GCP, we have Azure, we have all the large ones for sure, and some of the smaller ones. And the idea between the out-of-tree component is that we have just a Cloud Controller Manager, which does not have any code related to cloud providers. Like, there is no OpenStack code anymore in the future of Kube Controller Manager. And so we moved all the logic out of the tree and have our own repo, like the cloud provider OpenStack. And there we created the Cloud Controller Manager for OpenStack, which started as almost the same code as the in-tree one. And all the others do that as well, so that we don't have any code in Kubernetes core related to cloud providers in the future.
So
But,
am I understanding that you are doing a standalone Magnum or something? I'm still...
No, it's not standalone Magnum. It's like the Cloud Controller Manager is there to talk to your OpenStack API. It's there, well, specifically for the node management, like setting failure domains on the nodes from the VMs from OpenStack. And it also takes care on the service type load balancer. So creating the load balancer and adding all the nodes to the load balancer. And there's also a route component, which can utilize the Neutron router to set up a route. So that's also a thing how you can use Kubernetes on OpenStack without encapsulation. Is like when you propagate the routes on the router. But that comes with the disadvantage that you have to that each traffic has to go through the virtual router. But anyways, so
I would just like to mention that the OpenStack Cloud Controller Manager serves a very different purpose of the Magnum project, and the Cloud Controller Manager is used by default, and it is assumed that it's there and it's extremely useful to any, I think, Kubernetes deployments.
And
the in-tree removal, just as a comment, the in-tree removal was one of the greatest things that happened to us that are taking care of managing Kubernetes clusters.
So yeah, it is not. So it's an addition to Magnum, so to speak. Magnum is the deployment of a Kubernetes cluster, while the Cloud Controller Manager is something that sits in the cluster, watching for events for load balancer, for instance, and talking to OpenStack, bringing that in place. And this works on all Kubernetes clusters running on top of OpenStack. Technically, it also is possible to run it outside of the cluster, because it just needs to talk to the OpenStack API, even though it doesn't make much sense. Yeah. And with the removal, we have some advantages out of that. So when we were in-tree, we were pretty tied to the release cycle that Kubernetes does. And it was kind of difficult to get things into core just for your provider. And now it's fairly easy. And it's also fairly easy to implement the API if you like to roll your own stuff, because you don't have to compile it into Kubernetes anymore. And you don't have to maintain your own kube controller manager. You just have to build your own small controller, which is responsible for the parts you're interested in. Like,
So is it a OpenStack control plane over a Kubernetes cluster using Magnum?
it is installed on Kubernetes clusters that use Magnum, yes, in newer versions.
So how do you handle the namespace for the different clusters in the whole space?
It is running in the installed Kubernetes cluster. So it does not run outside of the cluster. It does not run in the OpenStack control plane, but rather it runs in your small Kubernetes cluster that you created via Magnum. So it runs, so to speak, it runs alongside the kube controller manager, which also runs in your cluster. Is that clear?
Yeah, kind of, but still I'm struggling to figure out what. So what's the purpose of this? Does it make something better? What is the uniqueness of this advantage?
The uniqueness, well, the uniqueness of bringing it or removing it from core Kubernetes is that we have smaller binaries and that we have better, or the code is more maintainable of kube controller manager. And the Kubernetes project decided that they want to have no dependency on any cloud provider in the core anymore. So we needed to extract that. So that was a push from the Kubernetes community that we must get rid of all the cloud provider specific code in Kubernetes core, which totally makes sense because I don't want to carry GCP code when I don't need to.
Yeah,
so,
that's the part of cluster API, I thought. Is this
no, the cluster API as it is just a provisioning mechanism like OpenStack Magnum. So you get your Kubernetes cluster up and running, that's fine. But when you use that cluster and then you create a service type load balancer,
correct?
Then a load balancer must create it somewhere. And this is what cloud provider OpenStack does.
I see. So the main you are saying uniqueness is to create the load balancer before even you do any cloud provider.
No, you are the cloud. So assume that you have a running cluster.
Correct.
Okay, and now you want to expose something to the internet. You must have you must have some way to create a load balancer. And in the old days, kube controller manager was responsible for doing that if it was configured with OpenStack. So, and now instead of configuring kube controller manager, we deploy the cloud controller manager for OpenStack with the correct credentials, and then it goes to Octavia and creates the load balancer and assigns all the nodes that are running in the cluster to the listener.
So got it. So if I interpret it, so if I put it this way, that you are replacing the Kubernetes API controller with the OpenStack API controller, and that will do the load balancing to start with, to support any cloud provider.
It's not the deployment phase. It's more the phase when you have a running cluster.
Okay.
So that you get traffic to your application that you deployed to Kubernetes. If you do an Nginx deployment, as an example, and then create a service load balancer, then you get traffic, you get a floating IP, and you get traffic through that load balancer to your Kubernetes service. Correct. So that's one of the purposes of the cloud provider OpenStack.
Sure.
And it also takes care on talking to OpenStack API and finds the failure domains for your nodes and sets the labels appropriately. like the availability zone in OpenStack reflects as a failure domain availability as a label on the node, so that you can technically deploy a cluster over multiple OpenStack availability zones. And then you can have an anti-affinity for some application you're deploying, so that all pods run in different availability zones. So that's also cloud provider OpenStack who enables that, who sets the correct labels. It doesn't do anything with the scheduling, but it sets the labels so that the scheduler can use them.
So Prakash, is it clear, or like if you want in the simple terms, like if you have an OpenStack cloud and Kubernetes you installed on top of it, so you want to leverage a volume management, like you want to use Cinder for volume management inside Kubernetes. So this project does it for you.
So
Yeah, I'm absorbing it, and I'll read myself before I can question. But this is see, Kubernetes on OpenStack and OpenStack on Kubernetes. These are actually inverted totally. So it does create
yeah,
some confusion.
it certainly does.
Yeah, it's basically Kubernetes on top of OpenStack. Simple.
Yeah, got it. Yeah.
Okay, and then we have a couple of other components. So that was the main component. But we have another thing. While I would, could you scroll down a little bit, please, to line, let's say 80? Thank you. So I would skip the ingress controller part for now, because the storage interface comes close to what we had before. So as I mentioned, Kubernetes wanted to get rid of all the stuff that is related to any cloud provider. So not just the things I mentioned before, but also storage. So before, storage was created also by the kube controller manager. It went to the Cinder API, created created a volume, attached it to the correct host. The kubelet had some code in place to mount it to the correct location, getting information about that, and so on. And all of that was also revised in the past, and people came up with the controller storage interface, or CSI. And we have a plugin for Cinder and as well for Manila. Yeah, and this is again the same, like you create a storage class as before. You have one of the plugins deployed, and if you create a stateful set, or if you create a PVC with the correct provider configured or the storage class configured, then you are able to create volumes and mount them to the correct location. And here again, the core idea behind that was to get rid of all the cloud provider specific code. In this case, the container storage interface is even broader than just specific to Kubernetes. In theory, each orchestrator, like let's say Nomad or Mesos, implements that. So you just need to have one code base for talking to OpenStack, and the specific orchestrator talks to your driver. So this is the advantage here. Okay, I wanted to.
I would like to ask a question regarding.
Yeah, welcome.
This. I think the container storage interface is great and works really well, but taking this pattern from this interface, would it be interesting for you that we maintain the cloud provider to have plugins for the provider? For example, if I want to add some hooks in the logic of the creation of the load balancer, to add hooks that could be either in the same way as the plugins that the kubelet has, like maybe a socket or something similar? Do you think it makes sense, or just adding it in tree with a good design with the community would be better? But this would also be a bit slower, and not all use cases are meant to be used by everyone.
Yeah, so I don't have a strong opinion on that, to be honest. I think that we should strive for having the best possible or the most default way implemented in the cloud provider. I'm not sure about, well, the idea with especially the load balancer, because this is a thing that I think is also up to this discussion, because I don't know if you know about the Service API version 2.
Yep.
I will
I've
put
read
the
about
link.
it a bit.
Yeah, maybe I find it. Otherwise, no, I don't find it. But I will add a link to that later, because this is the idea. Tim Hawkins is also involved into that. That we have Kubernetes. Let's must certainly go there to this one. So this API is meant to be close to what container storage interface is. Like you have a little bit more control over what you can create. You will have something like a gateway class. So that is something similar to storage class. Then you have something like a gateway that is again similar to a persistent volume, so to speak, like because the load balancer is brought in place. And then you have the routes that belong to the service. So then you can implement each and everything like you want to, and you just have to implement the parts you need. I think that's going to be the correct step forward.
This sounds great. Just a small follow-up. Do you think, or if you know, this will be like a loose API as the service type load balancer that we have now with annotations, or it will be stricter? Because I think this is one of the problems that led to the situation we have now.
Definitely, it does. It will be stricter. So because you can, the thing is, it's just referenced back and forth. So you can from your gateway, you can reference whatever implement the route you like to. So you can be very specific in that, because everything is a CRD. So the gateway class is a CRD, while the gateway is a CRD, and what brings the route in place is also a CRD. So you can be very specific at each point, and you can bring up new types that just is available in your cluster, and you just reference it from the gateway, for instance.
The final question, because of what you just mentioned, this will be the same for all cloud providers? It's not defined yet, or it will be different like we have now for all cloud providers like we have with annotations?
This is going to be for all cloud providers. So it's everyone can implement it like he or she wants. And I think there will be implementations for all the major cloud providers. So it's up to the idea behind this is to replace ingress and service type load balancer and combine it to ones which is close to how container storage interface works.
Thanks. Sounds great.
Okay, we had a poll, and people are struggling a little bit with the deployment of the OpenStack cloud provider, as I can see here. Is there anyone who wants to elaborate on that?
I would say, at least for us at CERN, it's not a struggle. We just miss a Helm chart that it would be great if we have. And I think we have it in our backlog to contribute it, but if also others need it, we can all push together towards that. But this is mostly a comment, it's not a struggle. I don't know how you feel about having a Helm chart about it.
Would be totally fine. If that helps people. It's just the OpenStack part is going to go way out of Kubernetes core. So we need to have a way for people that they feel comfortable to deploy the new style of things. So, and whatever works for you falls best.
Do you have another recommendation apart from the manifest and the Helm chart? Or is there another idea about it?
Not really. So we even didn't thought about the Helm chart, but but Helm chart might be a good idea, especially if you're using already Helm, then we can create one, or we can have one in tree. There are also other options these days, like kept packages, but I think people can use what people are used to use Helm these days, and it would be a good idea to have that in tree, I think.
I think the autoscaler is trying to adopt the Helm chart as well from Helm's chart and into the tree. Okay.
So according to the container storage interface, I have just another point that plays a little bit into the theme of, do you have long-running clusters or more cattle clusters? That was also in the previous discussion, I think, because this might be interesting for people using long-term clusters and you want to update. Because in the future, as I mentioned, the code is going to go away, but especially for the volume provisioning part, Kubernetes created a CSI migration. So that means you still have your old API for creating, or your old storage class for creating volumes and maintaining volumes. But under the cover, the Kube Controller Manager talks to the CSI plugin. And that is true for all cloud providers. It's not just specific to us. So I think people who run long-run clusters will need that feature in the future, so that you can still update your clusters, even if there is no Kubernetes, no OpenStack code in core Kubernetes, but you can still use all the old storage classes to be maintained.
I'm curious, roughly how's that going to work? Is there going to be kind of a mapping from, oh, we are using the in-tree Cinder one, you must be using CSI Cinder now? Is it that kind of thing?
The thing is, if you would like to migrate from the old one to the new one, and you just rotate out your old workloads, then you can happily just create a new storage class, make it as a default, and let it roll slowly. That's also possible.
Yeah.
So, but on the other hand, if you configure your Kubernetes and the controller manager and the kubelets to use the CSI migration, which is going to be on in the future, under the covers, the Kube controller manager still answers for all the volume provisioner it knows about and it was programmed for, but it reaches out for the let's say Cinder CSI plugin in our case.
Okay.
You know, so the way is the old one, but the Kube controller manager doesn't call the internal code, but it calls out for each of the other ones, and that's pretty great because it works for all the cloud providers.
That's neat.
And we just have one code path in Kubernetes core remaining.
So I have a dumb question. Suppose I have a PV provisioned by a sender in the cloud provider with the entry provider. And I now upgrade, and I can still work with that old PV using the original APIs because of what you just described. However, the new API give me new capabilities such as snapshots and topology support, to pick two examples. Can I use the new APIs with the old PV
No.
that was originally provisioned, or is it only compatible with the old APIs, but I can no longer will not have the new capabilities for it?
Well,
I'm phrasing the question well.
Technically, I'm not quite sure, but maybe that works. So it could be possible because the CSI driver knows about the volumes.
Yeah, I guess
So
I'll ask it as an issue, and maybe unless Anusha wants to tell me right now too. But it's something I puzzled about. You know, is you know, it will provide compatibility for the old PVs. But if I wanted to use the new APIs with the old PV, including new capabilities, you know, and presumably the new APIs would work for the same old capabilities. You know, like I could destroy the PV with the new API. I found the doc a little bit ambiguous.
I'm not sure if the old APIs the underlying translation will work, because it is not yet supported in Intri. So will that actually work? I'm a bit doubtful on that.
It sounds like you would have to have a magically auto-created new thing in order to be able to edit with the new APIs, wouldn't you? Within the Kubernetes namespace, right? I guess that's what you would want.
Yeah, I mean, it struck me that it might be possible because sender snapshots have been a thing forever, and sender topology, you know, on the OpenStack side have been there for some time. You know, so it's not like they were invented for the new CSI capability. But I guess the safe thing to assume would be you keep using the old PVs with the old APIs, and it will continue to work. And your data copied over to some new PVs for the future someday, so you don't have to keep using the old stuff forever.
Yeah, I think you could also just rewrite the provisioner of the PVC you had before, but that's usually not a good idea to fiddle around with that too much. It does work. I did that, but it might destroy something. So
it does sound a bit data lossy, for want of a better adjective.
Yeah.
It's interesting because it is like it seems like a mirror of the long-lived versus short-lived thing. Because obviously all of these PV, well, certainly with the new API, right, we could actually we can have an existing Nova volume that has my special stuff in that I'm connecting again through the new API. But if you created it in the first place as like an ephemeral Nova volume, then you're a bit stuffed, I guess. I'm guessing
yeah, it's a mirror, but in general, one wants the life cycle of volumes to be rather more stable than even clusters.
Yes, no, I think that's true. Yeah, because you'd want the multiple clusters when you've got the second cluster coming up. It may want to use the same data volume, I guess, at least in the manila sense.
In an ideal world where I've drunk all the Kool-Aid, I ought to be able to have short-lived clusters and nice YAML and persistent volumes, and be able to tear them down, not just scale them down to 0, save power, save money, and then come back next week and hook up to the same persistent volumes with the right YAML and just take off. Might be a little nervous about doing that sometimes, and people keep their clusters alive, but in theory.
I've seen that work with Manila for what it's worth. Works quite nicely with the SFMS Manila.
Anyway,
stuff.
thanks.
So
Okay.
yeah, we
Yeah,
have one question about the CSI migration. Does it feel ready now? So it is, it's in beta 1.17, so ideally it should work seamlessly. All yours should be migrated. So if anyone feels like anyone wants to share their experience about the CSI migration not going well or working well in your cluster.
I should probably own up because that question was me. I think I remember using it was either the Cinder one or the CephFS one, and I can't remember. I guess and maybe this is a question of me going to read the README on your repo, but is it clear which version of Kubernetes and which versions of cloud provider OpenStack means success with the CSI? I don't know if that makes sense.
A provider
maybe it's been working for ages.
Yeah, 1.18, I think we have moved to beta for 1.18. So we have all the jobs up and running, so it should work ideally. So
that was alpha before, wasn't it? Right. Okay, that's a good signal.
Is the deadline 1.22 or 1.21?
Yeah, it's 1.21 that will be entry will be removed. So it's suggested to migrate by that time.
Thank you.
And I see from the poll that there's a bit of challenges during upgrade. So I think upgrade as in with respect to which provider or any challenges with respect to that. Anyone would like to share on that? And yeah, deployment also feels like one of the issue that is being faced, I think 44%. So anyone would like to share what could be improved with respect to deployment, upgrade, or what issues?
Yeah, I came across some in the one Go, especially related to Go. It was because it has certain path 1.13 versus 1.14. There is a break there, and that was my observation.
So it's basically you have tried for Kubernetes upgradation or specifically for this project?
No, Kubernetes.
Kubernetes upgrade.
Are you talking about the Golang? Is it like the Golang upgrade you're talking about, or the Kubernetes upgrade?
Dependencies are there, right? So that makes it difficult to figure out, especially paths and where do they reside. And so maybe it was because of the path definition, but that was one which I faced directly. Struggled, but got over it finally.
So there is a change in using the dependency, like previously it used to be the dep and now it's go mode. So other than that, I don't think is there much. So you have faced with respect to using go mode because paths are not taken in with go mode, but it's required in dep dependencies.
Yeah, that's correct.
Yeah, it's a long time back, I think.
Yeah, that is because I had a old setup. So
Yeah, it's done across all the projects in Kubernetes. So I think using a mod is much easier. So maybe once you have migrated, you find much easier to use it there.
Yeah, once we switched to mod, it became easier. Yeah, that's correct. But this was one of the observations.
Yeah, and I think it improved very much on the 1.17 release of Kubernetes when they decided to add the tag 017 so that we can use it directly. I think some of the confusion could also be that the dependencies before were kind of clumsy and just with the git char and 0.0.0 as the release number, and the Kubernetes team decided to go with the versioning. If we are at v1.18, we also have the tag 0.18, so we can depend on that and go Modworks. Maybe that struggle comes out of that time. Okay, I wanted to, maybe we skip to the last point because we just have 3 minutes to go. I lost my slide here. And I just wanted to know a little bit, or we wanted to know a little bit about contributing to the project. So if you would like to contribute, if you know where to go, if we can provide any assistance, because it would be great for us to have more people on the project so that we create a good provider and a good environment for Kubernetes to run in, so on top of OpenStack for sure. Are there any thoughts about contributing?
You mean OpenStack provider?
Yeah, for the entire project. So like the CSI is, we do have all in one repo, what I mentioned so far. So we have the cloud provider manager, we have the CSI drivers that are also in the same tree.
So the one question which came about smooth attach and detach of volumes in the storage space, where you don't lose whatever you have, the older one, right? In PV especially. I would be interested in looking at that at least.
So I can provide a link to our repo if you like to.
Sure, go ahead.
Are there specific things that you as a team would like help with? You all as a team.
We need, when people don't want to contribute or can't contribute so far, we want to hear from people that are using this stuff, because it's interesting how people are using it and how people are struggling using it, because we are stepping forward all the time to not having OpenStack dependencies in Kubernetes anymore. And OpenStack, our team, we want to build a smooth environment for that. And we also want to be one of the good examples as cloud providers that are available for Kubernetes. So
yeah,
it would be
and
great if
also,
people, yeah, go ahead.
Yeah, we need help from documentation to testing, so we need all the help needed so we can increase testing, which is lacking in the project right now, and documentation also definitely can be improved in my opinion. So anyone could start at least on that, so that would be also much helpful.
I think to reiterate one of the points that was made earlier regarding simplifying the deployment. So more and more projects are moving to Helm charts, which are maintained by the projects themselves, because I think Helm, stable Helm repo, they're sort of trying to offload sort of lots of projects from their default repo. So as a start would be to set up like a GitHub pages or something for OpenStack Cloud Controller Manager, which hosts Helm charts for all of the sub projects within OpenStack Cloud Controller Manager. So one for CSI Cinder and one for Manila, and also for OpenStack Controller Manager itself. So yeah, making the deployment easier would be quite a good start.
Yeah, I think there's already support for Cinders and Manila plugins. So yeah, for the OpenStack Cloud Controller Manager, yeah, it could be definitely added.
Yeah, I think the people with the right privileges would probably need to make a